Hey boys and girls, today we're on page 173 and 174. We're starting with the on your own, number 3. It says that Jason makes a kite that is 3 and 7/12 feet tall and makes a kite that is 1 and 1/4 feet taller than Jason's kite. It wants us to do a couple things here actually. First, it wants me to draw a model to represent the problem and write an equation. Okay, so I'm just going to go ahead first and just identify some important things for us in our problem. Here I have Jason. Jason's kite is 3 and 7/12 feet tall and is a kite that is 1 and 1/4 feet taller than Jason's. Okay, and then the first thing it wants me to do is draw to model the problem, okay? And then it wants me to write an equation, okay? And then finally it wants me to answer, okay, how tall is Anne's kite? Because it's asking me how tall, this part right here is specifically asking me to give the answer with a label. Okay, so I'm just gonna write with label. Forgot the L. Okay, so at the very end, I do have to give an answer with a label. And our label here, as we can see, our measurements are in feet. Okay, so I'm going to do the first part of here, which is draw a model to represent the problem. So we're going to do a bar model like we did on number 1 for our Step It Out yesterday. So first I'm going to go ahead and I'm going to show Jason's kite. So I'm just going to write a J over here on the side so I know that I'm talking about Jason here. I'm going to draw my big part of my model. Sorry, that's a little crooked. Okay, I'm going to write the amount for how tall Jason's kite is, which I know is 3 and 7/12 feet. I'll put feet here just so I remember my unit. Okay, and then the next piece of information that it tells me is that Anne's kite is 1 1/4 feet longer. So it's this amount, the 3 and 7/12, plus the rest of the amount, which is 1 1/4. Okay, so I'm just going to make my bar a little bit longer. I don't know what it is, so I'm just going to put K over here for the amount for her kite. I'm going to put an A here so I know that I'm talking about Anne. And I'm just going to make a little note over here that this amount right here, which goes all the way from where Jason's kite stops until the end of Anne's kite, is 1 1/4 feet. Okay, so that's your drawing over there of the bar models. So I did the first part. The second part wants me to write an equation. Okay, so based on this, what can I say? Well, it looks like my equation is going to be my 3 and 7/12 plus this amount, the 1 and 1/4, to give me the total, which is how long Kate's kite is. Okay, so I can go ahead and write that either way. You can either start with K or you could say the 3 and 7/12 plus that 1 and 1/4. 1 and 1/4 equals K. Okay, and then what you're going to have to do is you're going to have to find this common denominator for these two so that you can go ahead and actually get the correct answer. And then remember, at the very end, you need to tell me how tall is Anne's kite. Okay, so do not forget to label at the end. So at the bottom over here, you can say that K equals whatever it equals, and then remember to put down feet. Okay, if you're not labeling your answers, it's incorrect. Okay, it's very simple. All right, number 4, pay attention to number 4. So it's talking about flour, and it wants you to do something after you check the measurements. So it says David has 3 and 1/4 cups of flour. He needs 2 3/4 cups to make biscuits, and another 2 3/4 cups to make baguettes. Does he have enough flour? Okay, so this is how much flour he has. Okay, so this is the total amount that he has, okay, in his house, wherever he is. He needs this much to make biscuits, and he needs this much to make the baguettes. Does he have enough flour? That's the first thing you need to answer. Does he have enough flour? That's goal number 1. Okay, I'm going to put down number 1 here so you know what you have to answer. And then the second part is how much flour does he need or have left over? So if he doesn't have enough, how much more does he need? If he does have enough, how much extra flour does he have? So I'm going to put number 2 over here for that part. That's your second goal to figure out. And your third goal is to explain. You got to tell me, how did you figure that out? Okay? And we're going to go over this during our web conference today at 11:30 a.m. Okay? So there's 3 parts to this problem. First, you got to figure out how much does he need? Does he have enough? If he does, tell me how much he has left over, or tell me how much more he needs, and then explain that. Okay? You should be explaining it as you're answering the questions. Finding number 5 on this page, it says that Mr. Lee's house has 2 stories. This word stories means floors or levels, okay? So he has 2 floors. Here's floor 1, and then floor 2 is right on top of it. And then on top of that, it says he has an attic, okay? So here's his attic. So there's 3 levels. That's his house, okay? It tells me that the first floor is 9.5 feet high. So here's my 9.5. It then says that the second floor is 8 3/4 high. Okay? And then it says that the entire house from here to all the way over here is 24 feet and 7/12 high. So it wants to figure out how tall is this attic. Okay, so what's the height of the attic? And then again, because it's asking for the height, remember you need to label. The label again for here is feet. Okay? Let's switch up all the way to number 6 on the next page. Notice for 6 and 7, it gives you specific directions over here on top in bold. It wants an addition equation and a related subtraction equation to model each of these problems. We did that again yesterday for number 2 in the Step It Out. Okay, so over here we have Roberta. She's working on a science project for 6.5 hours, and her friend Jocelyn works on a project for 2 hours and 2 2/4 hours longer than Roberta. Okay, so this is how much Roberta works, and 2 2/4 more than Roberta is how much Jocelyn works. Okay, what they want to know is how long does Jocelyn work on the project. Okay, that's your goal. So you got to write out your equation, show me an addition equation and a subtraction equation using these things. The letter that you can use for the amount of time that Jocelyn spends working on it is you could just say H for hours or P for project, whatever you want the letter to be, okay? If you want to just put it as J, you can just write it as J for Jocelyn's name, okay? Yep. And then we have, so I guess I can do an example for that one. So Roberta works on the science project for 6.5 hours, so I know that's how much Roberta works. So I'm just going to write down 6.5. And then her friend Jocelyn works for 2 2/4 hours longer than her. So that means that Jocelyn works 2 2/4 hours more than Roberta does. So if this is how much Roberta does, then I can just add that 2 2/4. And that gives me the amount that Jocelyn works. So I'm just going to put J. So if this is my addition equation, take this equation and write it as a subtraction equation over here. So it's going to be whatever number or letter, whatever it is, minus whatever number or letter equals whatever. Just make sure it makes sense, okay? And once you actually find your answer, make sure the equation works either way. And think about it. If this is my total, that must mean that this is my greatest number. So that most likely is going to go right here. So now what can you take away to still give you the other parts of this equation? And again, do not forget to answer your question and label. Okay, the label here is clearly hours because we're talking about time. Okay, all right. For number 7, again, 6 and 7 right here, it says it wants an addition equation and a related subtraction equation. So I'm not going to do the example for number 7 because I already gave it to you for number 6, but I'm just going to go through the problem. And it's pretty clear, especially since they drew a picture for you. It says a cricket jumps away from a frog, and then it takes a second jump. How many inches is the cricket's first jump? You can look at the picture. It tells you the total distance from the frog and the cricket, and then it shows you that it jumped the first time, and the second time it jumped 9 6/8 inches. How much did it jump the first time if the total jumping distance was 12 1/4 inches? Do not forget, you need the 2 types of equations, addition and subtraction, and then finally give me your answer with the label, and they told you what the unit of measure is. It's inches. Okay, over here, Lauren measures 2 1/4 cups of flour for a recipe. She realizes that she needs to add 2 3/4 cups of flour. Okay, so she's using this much, and she's like, oh wait, I need this much more. Okay, so she adds that amount onto it. What it wants to know is, does Lauren use more or less than 3 cups of flour? So she has 2 1/4. She adds another 2/3. Is the amount that she added, the new total, is that more than 3 cups or less than 3 cups? And then explain. Okay. A piece of quartz has a mass of 2.5 kilograms greater than the mass of granite. This right here is the granite. Okay. So this is the granite. And you can see in the picture that the mass of this granite is 6 4/5 kilograms. Okay, so that's how much the granite is. The quartz, which is what we're gonna find out the mass for, is 2.5 more kilograms than this granite. Okay, so this is my 6 4/5. The quartz is 2.5 kilograms greater than this granite. Write an equation to model the mass of the quartz. It does not tell you if it needs to be addition or subtraction. It's up to you, whichever one you feel more comfortable with in this situation. And then finally, what is the mass of the quartz? Okay, so after you've gotten your answer, please make sure to write it down and label. As you can see, the label here is kg, or if you want to go ahead and write it out, you can say kilograms. Okay, as always, boys and girls, if you have any questions, please comment below. And our video conference today is going to be at 11:30 a.m. Bye.